Hello, this video is for IXL Activity A1.H.5. It is titled Identify Equivalent Equations. The 3-character code for this activity is X-ray November Quebec. So it says to select all of the equations below that are equivalent to 8 equals 18 minus k. And they want us to use properties of equality. Remember, properties of equality is all about what you do to one side, you have to do to the other side as well. So if we look at this here, let's identify what's the same. On the right, we see the 18 minus k. And all of these here, we have 18 minus k each time. So let's go ahead and identify those. And then look and see what we're doing. Well, we're subtracting 4 here, right? So if we start with the 8 that we had up here and subtract 4 from the left as well, 8 minus 4, well, this equals 4, not 2, so we know that this is incorrect. Here we have the 8 that would be on the left, and over here they're subtracting 6, so 8 minus 6, well, that equals 2, not 4. So this one is incorrect as well. As we move along to check the next one, here we would have the 8 that was on the left from up here, and here we're subtracting 2 from the right, so 8 minus 2. In this case, 8 minus 2 is 6, so this one is not correct. Well, I hope this last one is. So on this one here, we start with the 8, and it looks like we're subtracting 5 on the right, so 8 minus 5. This equals 3, which matches up with the 3 that we have here, so we see that this is the correct answer. It is the only correct answer. It says select all, so be careful. There could be more than one correct answer. So we found that by looking to see what did they do to one side and then check and see if they did the same thing to the other side as well. Next question, select all the equations below that are equivalent to 2 equals m times n. Use properties of equality. Well, it looks like we're doing something to the right over here on the right side because we have m times n on all of these 4 examples here. So let's look and see what they're doing to the right. And then we'll check and see, did they do the same thing to the left as well? So it looks like we're adding 9 to it. So if we start with 2 and we add 9, this equals 11. Well, not 12, so this would be incorrect. Over here we start with 2. Again, getting the 2 from up here, right? And it looks like they're adding 6, so let's add 6 to that. 2 plus 6 is 8, not 10, so this is incorrect. Over here they're adding 3 to it, so if we have 2 plus 3 equals 5, indeed this checks out, so this is correct right here. So this one's a correct answer. And it also looks like on this one they're adding 15, so if we do 2 plus 15, well, that equals 17, right? Not 19, so this one would be incorrect as well. Our only correct answer is this selection here. Select all the equations below that are equivalent to negative 15 equals u plus v. So looks like our u plus v is here on the right side of the equation as it is up here in the original equation. So let's identify all of those. The next thing to do is see what are they doing to it. Well, over here it looks like they're multiplying times 3, and we're starting with negative 15 on each time. Negative 15 times 3. This indeed equals negative 45, which checks out with this here, so this one's correct. Here it looks like they're multiplying by negative 2, so negative 2 times negative 15. Indeed, this does equal a positive 30, so this one checks out as well. Over here we're multiplying by negative 3, so negative 3 times negative 15. Negative times negative is positive. And 3 times 15 is indeed 45, so this one's correct also. So far we've got 3 of them that are correct. And then finally, last example here, we're multiplying times negative 5. So we'll multiply negative 5 times negative 15. And negative times negative is positive. And 5 times 15 is indeed 75. So this one checks out as well. And it turns out that all 4 of these are correct. On the next one here, we have on the left, we have q minus negative 25. So q minus negative 25 appears to be in all of these examples. Now we need to see what are they doing to q minus 25, or the quantity of q minus 25. And are they also doing that to the right? So over here we see it that it's being multiplied times negative 10. So negative 10 times, and this time we're getting it from the right side up here, negative 6. Negative times negative is positive. 10 times 6 is 60. This checks out with that there, so indeed this one is correct. On the next one, we've got our positive 13 being multiplied times the quantity of q minus negative 25. So let's take that 13, multiply it times the negative 6 up here, negative 6. So positive times negative is negative, so that checks out. It is negative 52. And 6 times 13, 6 times, well, this isn't going to be right, because 6 times 10 is 60, so I know it's going to be more than 60, so I'm past 52. It would actually be 60 and 18, 78? That'd be negative 78, which is not equal to negative 52, so this one is incorrect. Over here, I have, oh, good, 13 again, right? So we know we got 13 times, and bring our negative 6 here, negative 6, and we already know that equals negative 78, and looky there, there it is. So this one is correct. And then we have negative 16 is being multiplied times the quantity of q minus negative 25. So if the left is being multiplied by negative 16, we're going to multiply the right by negative 16 as well. Remember, we're multiplying by what we have up here, not what you see down here. So negative 6. And we are trying to get to the target, where if our product is equal to this, then we know we're good to go. Negative times negative is positive. 6 times 16, well, 6 times 10 is 60. 6 times 6 is 36. 60 plus 36 is indeed 96, and that's what we have here. So in this case, we had 3 correct answers out of the 4. On the next one here, we have negative 33 equals negative 55w. So what's being changed? It looks like it's the left side, okay? We have negative 33 here. How do I want to highlight that? Just put a little check mark there. Negative 33. Now they're switching back and forth. So we're going to have to just do them one at a time. So here, negative 33 is being divided by 11 over here. So if we took negative 55w, what we have up here, and divide it by 11 as well, what would we get? Oh, we're dividing by negative 11, aren't we? That's important. Negative divided by negative equals positive. 55 divided by 11 is indeed 5. We still have the w, so indeed this one checks out. On the next one, looks like this time we're dividing the right by positive 11. So over here we have negative 33, and if we divide by positive 11, negative divided by positive equals a negative. 33 divided by 11 is 3, so that would equal negative 3, which is what we have here. So this one checks out as well. Again, this time they're kind of switching back and forth. Last time they were doing something to the left and we had to do it to the right. Now they're doing something to the right, so we had to do it to the left. So let's look and see what we got here on this time. It looks like here that they have divided the left by negative 5, right? Over here we see negative 33 is being divided by negative 5. So let's take that negative 55w, what we have on the right up here. Let's also divide it by negative 5. We're dividing by negative 5 because that's what they did to the left. And in this case, negative divided by negative is positive. 55 divided by 5 is indeed 11, and we still have our w, so 11w. This one checks out as well. On the next one, it looks like we're dividing negative 33 by negative 11. So let's go ahead and take negative 55w, and we're going to divide it by negative 11, which we're dividing by negative 11 because that's what they did to the left, right? Now we're trying to see, do we get 6w? Well, in this case, negative divided by negative is positive. That part checks out. 55 divided by 11 equals 5, and we'd still have the w, and 5w is not the same as 6w, so this one would be incorrect. On the next one here, select all the equations below that are equivalent to q over r equals negative 63. This one's going to be interesting. Over here, what do we see that's different? We see that the denominator here is r times 3. So what they've done is they have taken 1 over 3 and multiplied it times q over R. So here's our Q over R right here. We're multiplying by 1/3. Well, 1 times Q equals Q, and 3 times R equals R times 3. So we realize that they're multiplying times 1/3. So 1/3 times negative 63. And I'm going to represent negative 63 as a fraction, so I can do fractions times fractions. And now I'm going to end up with, that's going to equal negative 63 over 3. Now I need to simplify this. Negative divided by negative is a negative. 63 divided by 3, well, 3 will go into 30 10 times, means it's going to go into 60 20 times. And one more 3, because of 63, that would actually be 21. So it'd be negative 21, not negative 22. So this one is incorrect. Ooh, negative 21. See that over here? Look over here on this one. Here we had the same thing over here as we do over here. So we just solved for this one here. We know this one is correct with our work that we did there. Next time we have here, looks like 9 is being multiplied times R. So we're taking 1 over 9, multiplying it times Q over R. 1 times Q is Q, 9 times R is 9R. So we're multiplying by 1 over 9. So let's take 1 over 9, multiply it times negative 63. I'm getting that negative 63 from up here. I'm making it a fraction so that I can do fractions times fractions. 1 times negative 63 is negative 63. And 9 times 1 is 9. Next, we need to go ahead and simplify this negative 63 over 9. Well, remember, every fraction is a division problem. A negative divided by a positive is a negative. 63 divided by 9 is indeed 7, correct? So negative 7 matches up with negative 7 here, so this one checks out. On the next one here, looks like R is being multiplied times 21. Well, we would get that by doing 1 over 21 times Q over R. 1 times Q would be Q. 21 times R would be R times 21. So we're multiplying the left by 1 over 21. So let's multiply the right. 1 over 20, not 12, Mr. T, 21. And we're multiplying times, remember, we're getting the number from up here, negative 63, and I'm making it a fraction so that I can do fraction times fraction. So I'm going to end up with negative 63 over 21. Now let's go ahead and simplify this. Negative divided by a positive is negative. 63 divided by 21 is 3. Negative 3, negative 3, that checks out. So these two, that's also an equivalent fraction to the initial, an equivalent equation to the initial equation that we had. Last example here, I have C minus D equals 9. So let's look and see what we got here. C minus D. You might be thinking, oh, this is an easy one again. And this is from the 90s. This is a higher question. Sometimes you'll be surprised. You'll get through the 80s and it'll be difficult. You get to the 90s and all of a sudden they start throwing easy questions at you again. So let's find our C over D on each of these and then see what we're doing to each side. So C over D, and they're adding a negative 4. They're subtracting 4, we might say. So let's take what we have up here, minus 4. 9 minus 4 equals 5. Indeed, they match up. So let's go ahead and rule this one is correct. The next one, we're subtracting 7. So let's do 9 minus 7. Well, that equals 2, not 4. So this one is incorrect. Here we are subtracting 2. So let's do 9 minus 2. That equals, what, 7, right? Not 8. So this one is incorrect. And then over here on the left, we're subtracting 3. So let's do 9 minus 3 equals, well, that equals 6, not 5. So this one is incorrect as well. So it turns out to be that just the first one was correct on this one. Remember, the key is to realize, to look and see what are they doing to one side, and then if we do the same thing to the other side, do we get the answer that they give here on these possible answers here. All right, so that is all I've got for examples from IXL A1.H.5 Identify Equivalent Equations, and good luck with your activity.